Hello there. This is the third attempt at doing the explanation thing about our latest four small intros. Let's hope everything works. Last time I had 2 consecutive GPU crashes and it was basically impossible to continue because streaming takes less time than us. I'm allowed to stream. I can stream for less periods of time that reboot takes. So yeah, it's not really that convenient. So I've did a few things to my personal computer, and let's hope that they will improve things a bit. So I guess welcome to the stream. And today I will start with, not start, but continue with second intro I was explaining, which is cock. I think I made it work last time. But yeah, for some reason, capture stream frames per second are even lower than last time. So yeah, this is the thing which we made for KS Constructions at the end of August this year. And да, всем привет, я по-русски-то совсем забыл сказать. В общем, это я буду продолжать рассказывать про наши последние 4 маленькие интры. Стрим будет на английском. Если что непонятно, задавайте вопросы на русском, буду отвечать на русском. Привет всем в чате. Привет ГКРК, там, по-моему, Боча еще был, да? Я почему-то чат уехал, я тоже не вижу. Привет, Боча, привет. Там еще пара человек было, и не успел прочитать. Простите, я тут забегался. Так. Я не помню, где мы остановились. I can't remember what I was talking about the last time before my GPU crashed. I guess it's I will just start explaining it, like how it works, and yeah. So first of all, there's this tool, which all 4 of these intros were made with a new tool, which is not really a tool, which is like quickly hacked together for me to be able to do anything. It was made for 64K intros, so it kind of has this specific design for the specific 64K intro I was trying to make, which ended up with a название 64K intro that I showed you on the last stream 2 weeks ago. And all other intros basically were made by slightly modifying the tool. The tool is really simple. I probably showed you the last time, but I guess it makes sense to reiterate. This intro is 4K intro. This one is 4K intro, but the tool it was made with was targeting 64K intros. So yeah, the tool uses my Eto library for quickly getting a OpenGL window in like hassle-free. I don't like SDL and stuff like this. Let me close this. It will be easier for me to work with higher frames per second. So yeah, basically you get the tool is already given a window when the tool's main function, which is this application init function, gets control. It already has a window OpenGL context. So it reads audio from pre-generated audio as usual for as I do with Forclan synthesizer. I just pre-export the audio into this raw file that I can just pipe into the sound card. I also do this crap, which is not really needed here. But yeah, it's for me to be able to control the scene that I work on, like start and end time and loop control. And yeah, other things that tool does is just some key input, like being able to skip forward and backwards with arrow keys, pausing, and loop control. Yeah, basically that is just start loop, end loop, and disable loop. All of these are on a single key. There's just some time logic and resize, window resizing, and audio, like just for audio to be able to loop on the same time as video. That's it. Like the control thing for the tool is really, really simple. For the video part is basically a rewrite of the название that which is just code is the same, but initialization and draw function is changed for the 4K intro scene, which is like two passes. There are two render passes. The first one renders the main scene with blending enabled, so it blends with previous frame. And the next pass is just outputting this frame buffer into screen with doing some like color correction and crap. It doesn't really do much there. Gekark asks, will I do simple physics? As a matter of fact, I did write a bit physics like 3 or 5 years ago. I don't really remember. So it was particle based. It was SPH, fluid simulation. It was really broken and not really interesting. But yeah, I contemplate trying to make a proper fluid simulation in 4K intro, like with millions of particles in real time. That is on my list of things I would like to do. Okay, so this part is really simple. Привет, остров. And render pass is also like I explained it with название, so I'm just explaining the things that are different, which is not really much. Like this whole 4K intro is basically the one scene from the 64K one, so everything else got deleted. And the scene, as you can see, it's this one with this is a post-racist scene with one wall, one floor, two balls, and a cube between them. And the cube is just there's meta balls. This meta thing is done with this function. I think I already talked about it last time. So yeah, but there are actually two scenes in this 4K intro, but they are both of them are made within the single shader, and they are controlled with. No, this is camera control basically. Not really convenient, but really fast to iterate. and try things out. So yeah, this is camera control. This is not really interesting. Doesn't make any sense to explain it on stream. All those numbers. This is sun direction, which is the idea there is to be able to do this sunset like effect. So this intro not only has path tracing, it also has realistic atmospheric scattering in it. Which gives a really nice shading in the second scene, which has colors. So as you remember, this one, this scene is black and white, and then you have this part where it goes. The idea here is to to make a viewer think that this is the end, but this is not the end. So here's the atmospheric scattering at work. Basically doing this thing properly is what gives this intro like this really cool look that I personally like. I won't deny it. I like this. But as you can see, like, geometry is really simple. There's this floor, there's this really stupid, really straightforward distance function thing with really simple CSG, where this is a box cut out of a box, slightly larger box, and then there are repeated boxes that are cut out from this box. Yeah, just a lot of intersecting and intersecting boxes, basically. So this is geometry of the scene is really simple. Yeah, everything is simple, like. So scattering is taken from the appear intro with a slight optimization. Like, we don't do clouds here, and we don't do any. And I also optimized a bit, like removing clouds. It lets me optimize this function a bit. So it's not really interesting to talk about. Like, I have these. Let me find it this way. If you want to know how the scattering works, there's this short write-up that I made on this thing. You can check it out. Yeah, it's kind of tribute to Nobis stuff, because like he was the first person who well, among the first. I'm not sure like whether he was like first one, but he was the first one who did make this really cool look of simple objects and lighting, and yeah, basically it's like his style. I won't deny it. Just I find it really cool, and I wanted to play with it myself. But also kind of add the twist to that, like make it a little bit more complex, I'd say. So yeah, this if you want the you can see the URL, right? Because there are GPU crashes. Let me just post it into the chat. Okay. So for some reason, Restream complains about Facebook chat. I'm not sure what's going on there. Okay, so this is explained. Okay, and what there's this function for balls. They were supposed to have different material. They do have different material. So yeah, I make them a separate function for that to be able to distinguish from them between them and other stuff. And then there's a room which is also different material, and room is like this large box, and also large box cut out of there's box cut out of all the space. It's kind of in reverse. And then there's larger box. You might think as a larger box and smaller box cut out from it, like it's basically the same but kind of reversed in these functions here. And although these repeated boxes which are moving according to the sun direction. So to get this animation, just reuse the sun direction to be able to move them. Just it's a random thing. It's not a really good decision. So, and although they have room size and window size modulated with time in main function, so these are variables. Metabox is what? Metabox is the box that is moving between the balls. And then the global combined world distance function is just balls, which are constant. And then between these times I do the metamin with metabox. And otherwise it's just room and balls combined. And that's it. And normal as usual, march functions, function is not really interesting. Do I use it for something else? No, I only use it once, so it's not really like supposed to be separate function. If I inlined it here, it could be a bit smaller, but it's like, okay. I did fit within the size limit nevertheless. So, and there's only single effect here, which is like not like path tracing. There's this path tracing log 16 samples per pixel, and this is the I'm not proud with, which is like it doesn't do any anti-aliasing per pixel, so it's always like the same ray direction for each sample of per pixel. And yeah, I just forgot to do that. I fixed that in next intro. In next intro that uses path tracing, which I will be talking about today too. And then there are four ray reflections per sample. So first of all, I calculate the escape distance for the ray, which is like distance at which the ray escapes atmosphere. This is needed for scattering. And really this function is just a ray sphere intersection from within the sphere. And that's it. It also used in the scattering function because there are basically for along the ray from camera to some object, you do this second scattering ray to the sun, which is like first approximation on what's going on in real scattering. Okay. Is anyone watching me? Like, is this interesting? Okay, next thing is like material index. And then I guess I do some approximation with firewall. This is weird. I don't remember the X. This is floor. Yeah, this is floor. So besides distance function geometry, I also have this analytic floor. Which has material 1. Material 0 is atmosphere. And then also I march the distance function. We limiting its size to like max distance, ray distance is 20 and maximum 40 steps. These are I forgot the word. Something. Okay, this just I tweaked these for it to have as little artifacts as possible. And the entire ray-marched geometry has material too. Then there are usual path tracing. Usual for my type of path tracing parameters, which is like emissive, color, albedo, normal, and roughness. I talked how my path tracing model works before, and yeah, it's really dumb and simple. It's not physically correct in the sense of photon material interaction. Okay, so if we are hitting atmosphere and not hitting any other geometry, we do there's only emissive color, which is like scattering. So this means that this ray will get color according to the atmospheric scattering and nothing else. Here's this thing that I need to do. Otherwise, let me show you what happens. Like sometimes there are bad things happen to numerical stability there. And you could probably I guess, no, you can see like this black pixel here. Sometimes there are, and here, so this is basically what happens. They start creeping a lot. So what's going on there is like because of some not numerical instabilities in like in a strict sense, but there are issues with like a lot of rays and a lot of what's going on here is random. So sometimes a ray can get into some position that results in like division by 0 or some crap like that. For some reason, I did try to find the exact culprit of this thing, and I wasn't able to, and I had to release. So this is what I do. Just if we got something that is not a number, then we just discard this ray, and that's it. The thing is, like, if you got a floating point nan, like not a number, it starts to poison everything around it. So basically anything else that is anything that any value that depends on this value will be poisoned and will also get a not a number. And this will result in this total color thing also getting not a number, and this frag color getting not a number. And the final pixel that is stored in frame buffer texture is floating point one, so it will also be not a number. And then we will blend it with the previous frame, and this blend operation will also get not a number. And even if on some next frame we get a normal regular number for this pixel, it will get blended with not a number and with also like result in not a number. So this pixel is broken forever unless blending operation doesn't happen and it's rewritten. So so basically when working on this thing, this black not a number pixels start creeping in and just they fill the entire screen this time. So yeah, this is the simplest way to deal with that I devised. And yeah, like we got an atmosphere color emissive, and albedo doesn't make any sense, like there's nothing to interact with. Then yeah, and otherwise this is just a bit weird because I need to have this calculates ray position for the next ray sample, but I have to Arusius, thanks for following. Thank you, or thanks. So here's the thing. For this scatter function, I need to have this current ray position, so I can't really calculate this one. But for other materials, I do have to have like already have the position of ray geometry intersection calculated. So there's that. Just a little inconvenience here. So otherwise, if we hit something, so we check like if this material one, this means this is floor, and floor has this also really like usual for me and probably many other graphics people. This floor with water, with puddles, or like how do you call them in English? Little pools of water or whatever. And this is like roughness 0, which means really smooth, watery kind of surface, plus some fractal noise. And yeah, this is also like tweaked a lot. It doesn't, there's no physical meaning behind this. I just tried some random numbers and stuck with those that looked kind of okay. The second material is ray march scene, and for that we calculate normal, we calculate next ray starting position at a slight offset from the actual one, because we need to have because otherwise the next if we start at this intersection position, we will have itself as an intersection position, and it's not really correct. So yeah, This is usual, like when doing reflections with reinforced geometry. There are other ways, like starting with offset from reflect ray, but I prefer this for no good reason. And then we have to distinguish from balls material and room material. If balls distance is larger than the room, which means like room is closer than the balls, which means like we hit room geometry. And this is really regular, like roughness, some concrete like material. And this one is, I believe, this is the this one, this moving lights on the far wall. So yeah, just how to explain this? So we have our coordinates on the wall, like x and y, and we get the cell number, like basically a pixel number, which is like floor of those values. Gekark asks, will I switch to Vulkan? I want to try Vulkan, but I have so many things that I would like to do before that. Like it's low on my priority list. Maybe sometime if I come up with some effect that is easier to do on Vulkan or something. Okay, for this thing, we basically depend on Привет, Rina. Pixel coordinate, like large pixel coordinate on the wall. Привет, Pavel. And this is mass to get I don't really remember how this works, but I mean, like here's the position, like this is a cursor of whether like of the point that where light should start, and it moves with time, and it also depends on random value that's calculated based on a y coordinate. So each line, there are several lines, and each line will have different light starting position. And then so here's like starting position, and here's end position, which is also random. So these light stripes will have different length. And this is really stupid because I switch off the lights based on no, this is not really stupid. This is basically to get this effect when lights go off at the end of the first part of the intro. So basically there's this time limit that goes with the lights. So everything behind this line will be black. Привет, Kim. Gekark asks he wonders whether there are special math functions for ray tracing in Vulkan, and I believe there are no such things, at least at this point. I haven't read about it. Vulkan also supports extensions, but well, I haven't read about it, so I think I would hear about it if there were such things. Okay, and second, like else case is a balls material, which is like just the same thing with a water on the floor, which is like completely reflective plus some fractal noise to get these weird areas with which are not reflective. And then there's color calculation for the past tracing, and although early out in case we don't have anything else, if the next ray color contribution will be too low to notice, we just we just out, don't continue. Reflect and add randomness to the reflected ray based on roughness. Not really physical, but looks good enough. And then just to have this sample hemisphere in the right direction. It doesn't make any sense to sample rays behind the normal. Yeah. Okay, that's basically it for the 4K intro for case construction. Yeah, Blitter is really simple. What does it does color correction, plus it does this thing I talked about it earlier. Basically, this is half resolution. Only this part is rendered, but the blitter extends to the entire frame, and you can see these vertical stripes here that are a sign of that. Also, like I talked about it before when I talked about Nazvania. So this is 4K intro for case construction. This is done. Wonderprince, привет. Нет, я не был на ЦЦ ни разу. В очень неудобное время. Конец августа — самое стрёмное время для путешествий вообще. So Wonderprince asked whether I visited, have I visited CC before myself, and basically I didn't, because it always at the most inconvenient time for me to travel. Okay, so the next intro was mid-school. This is a bit weird. I will show you on YouTube because I don't have like text rendering done on Linux. But I will show you how it's made, and like this is the most straightforward intro that we made this year, I think. Penguin, почерк, привет. Yeah, sorry, I forgot the switch back the mic. So yeah, this is our little intro for River Rush demo party. Kin made all the amazing music in it, and I made all the visuals. And this is a bit weird because it doesn't have all these past racing like clever effects or something. So the idea behind this, as you saw, like let me show it here. All the greetings here are for the older demo groups, which is like from late 90s and early noughties. And basically this is a tribute to all of them, and as you can see, like these effects are trying to make those like mid-school effects. Well, I consider the time mid-school because like there's old school, which is like 80s and early 90s, which all these old platforms like Amiga, C64, like Spectrum or whatever. And then there's this new school, which is like contemporary-ish intros of late noughties and early 10s. And the like complex 3D graphics. And then there's this transition period whether like people were fighting about like is using like 3D accelerators is good or not, like for demo scene. Yeah, and this period is mid school, and basically and also this is the time when I was which is the right verb for this in English? Like I was in mid school, like I was a student, and I was like 14, 15 years old, and I made a contact with the demo scene. I saw these demos and I was amazed, and I immediately wanted to be a part of it. And like it was a long ago, it was basically year 2000 or something. And as you probably know, like this is the time around like 14, 15 years old is the time where each person gets his or her tastes forms like fixed or something. So, and this is like the time for which you will feel nostalgia for the rest of your life, basically. So I still find demos of that time like the most influential for me, and this is a little tribute where I try to make these effects in this intro. So let's try to run it. So basically the same tool is the same. Керхардшредер, привет. Ритрейсинг? Нет, не на процессе. Это все ГПУ, это все реймарчинг. Это все реймарчинг. So, basically, this is shader raymarching, as usual. There's only one like not raymarching effect, which is like this radial blur here, which is done like as usual. There are like two steps, which is like first render intro and then bleed it to the screen, and bleed it to screen does this radial blur effect here. Okay, probably should make music a little bit quieter. Yeah, something like this. Okay, so idea of this intro. I wanted to make something like this for at least a couple of years, I think, and I was on a vacation and I thought that this would be a good opportunity to try to make something like this. And basically, the idea, as Kin says in chat, is like for modern hardware is really easy to make a lot of stuff with like ray marching, like complex 2D stuff in ray marching in little space. So here's what I do basically here. There's this giant world function and a giant if else statement in it, like for scene number 1, scene number 2, scene number 3, and so on. And yeah, so basically make a lot of scenes that looks like old demos. So I can even show you a few inspirations for these scenes. I think I can find them. And as you can see, like this is really simple. No rendering is really fast, so it's 60 frames per second, even like on capture. Like it's 140 frames per second for my. It's basically limited by VSync. So yeah, it's amazingly fast. Even though I haven't tried to make it fast, like just modern hardware doing things for me. So yeah, just scene with cubes like replay style. Okay, let me show you. Replay. Pull sequence intern. It's not that one. Release date. Forms maybe. Not forms. This one. No, not this one. Not this one either. But kind of this style with really simple boxes. Can't find it, sorry. Co один привет. Yeah, basically this style of really simple Chert be bother, thank you for following. Not exactly this effect, but yeah. And like replay in demos and intros, music by Mosaic is like the best stuff there is. Just as I was saying, like I stumbled upon demo scene at the time, and I was 14, and my taste is fixed at that age. Yeah, this is Puyet. I don't know how to pronounce it properly in English, but whatever. Puyet. And its design is basically from 2000. Del01 thanks you for thank you for following. Why do I say thanks you? This is stupid. Forms? Not forms. I already looked at forms. There's what like Yeah. As you can see, like stuff like these squares and yeah. Okay. For what thanks you, yeah. So this is like the first thing. This is not reference to anything. I just tried to make a few like overlay 2D effects, which are completely separate thing here. As you can see, each scene has there's this auto giant if based on time, where I select which scene will be shown, and scene numbers are not really in chronological order. They were in order that I made them in, so it's that like that. And then there's basically in this giant if we calculate the color and overlay. Color is background and overlay is the color on top. So here's this thing of like circles, and this circle function is something that calculates let me show you it like this. Yeah, so inner radius, outer radius, repetition count and stuff like that. Congratulations, Tsorin. Do you do like random, not axis aligned planes, which like for axis aligned planes is just really trivial, but for like random planes, what's your parameterization? You like have normal and offset, right? You can do path tracing now. Make it like many samples per ray. So yeah, I tried to make these many like 2D effects, but I made only circles and didn't come up with any good scene to show that. So this is basically just a placeholder for whatever. Idea here again was there are a lot of 2D intros with 2D overlay things. For example, this one. Also, like this is classic. Yeah, you can see this 3D scene and some 2D crap about it. These things, these. Yeah, I just basically ran out of time and ideas to do something like this. Yeah, you can see like moving things up and down, just yeah, these. It's so cool. I wanted to make something like it. Okay, next scene. This is basically to show off the intersections, which is also like a cool effect for the time, because doing this 3D CSG stuff is not trivial. It requires like quite a bit of thinking to do. and it was like a cool demo effect to show off. And here, because this is Ray Martin doing 3D shapes, is trivial. What is not trivial, like not really straightforward to do, is these lines. So these lines are basically let me show you this. This is fun. This is scene number scene number 1. Okay, number 1. Scene number 1. So why is it? What? Okay, this doesn't change anything for some reason. So the idea here is that this is actually a lot of boxes. So here's there's this central box bound in one, and if I do like this, if I do it like this, you will see what I'm talking about. This is just a bounding box with parts of it cut out with a slightly smaller boxes. So if I do, for example, like this, you will see what I'm talking about. So yeah, there's just boxes intersecting. So basically, to get the lines, I do a lot of CSG operations here. And lines are to show off the CSG red CSG cube at the center. Tech Storm Crow, hello. Is your i3 active border thicker than other borders? This is not i3. This is awesome. And this is basically awesome with default configuration because that's what works for me. I set to here that Sodin. Good luck with your network. Okay, so the lines are actually more complex than the cube intersection here. And reference for that effect is, I think, okay, I don't. This one. So it was like it took a 9th place at Assembly 2000, but I like this demo a lot. It has really cool music, which gives like this really cool atmosphere, and so yeah, basically the reference. Мановый привет. Were there any other references from this one? I don't think so. Okay. Yeah, this is another fun thing that every other demo or intro in 90s were like trying to show off metaballs, and they used marching cubes for that. Marching cubes is really neat technique. Marching cubes. I also I implemented it myself a couple of times. So basically the idea there is to... Why is it in Russian? The idea is that you divide space in this grid of equally sized cubes, and not really important if they equal size, but yeah, you just gridify your space, and then for each point at the... How do they say it in English? Vertex. At each cube vertex, you calculate some potential scalar field value, and then you have this polygonization process, which is like you are trying to build a surface for where this scalar field value has some specific value. So yeah, for each cube you have its 8 vertices, and given the state, you mark each vertex if it's lower than the border value of higher than that. Let's for simplicity, the surface value is 0. So for each vertex, it's if it's less or greater than 0. And there are many, they say there's 15, but I don't remember the number myself. There are several configurations of these of possible less or greater than 0 combinations for vertices, and this is the method to reconstruct this surface based on those things. There's a lot of tables to solve each case. So yeah, you do this metaball field and polygonize it using Martian cubes, and it is possible in real time for 19th computers. So yeah. Welcome back, Sonny. Code Kick, hello. Welcome to the stream. So yeah, and it looked like this. Okay, this one is out. Oh yeah, I tried to do quick text for this intro on Linux before the stream, but I ran out of time. And TBL, I think. Black Lotus. Maybe this one. No, not this one. This one. I think this one has this. No, not this one. This one also has this Martian cubes thing. I believe this Martian cubes. I don't know there were any other known techniques for polygonization of scalar fields at the time. There are quite a few now, but then I don't think so. And you can see like why this intro is not a reference here, because it has a different lighting model. But you can see like this is how this Martian cubes looks like. Really rough triangles. Let me show you other intro, other demo for the reference. It's difficult to jump between your Twitch streams. Your Twitch description contains links to your channel within this playlist. There's the problem that I don't really know the proper URL for my YouTube channel. For some reason, it's either this really weird random long random string, or the short one, but I always forget the short one, and like it's weird. But yeah, I know what you mean. I will think about it. How to do that. Like, I don't really like what YouTube does with like channel front page. Okay. Another reference. This one. I also like this demo a lot. It's so amazing. It's my childhood experience. And also amazing music, as yeah. So yeah, this is the scene. What? I think there were a better capture of this. Why? Okay, let's search YouTube. This is the same URL, right? Yeah, this is the same. And other stuff is random, unrelated crap. Okay, I thought there was better capture of this. Okay, thank you, Sadin. Interesting. I also would like to change my nickname on YouTube, but I don't think that's possible. So yeah, look carefully. There are your metaballs and the flat shading triangles. So a lot of demos contains an effect like this. So what I do here is to get the look. Basically, my metaballs here are true metaballs, and they are quite a bit more detailed. As you can see, the edges are smooth, not like jagged as for triangles. Because I do remerge this thing and making, and yeah, I couldn't come up with technique to properly jag my geometry there. So what I do to fake this is this is scene number, let me figure this out. Scene number 4. Scene number 4 is I basically floor the coordinates for my normal. So if I disable this, you will get perfectly smooth metaballs, which doesn't fit here. I want them to look like polygonized crap. Retivit, thank you for following. For Warhammer 19 was on a list for scenes that I would like to do, but I didn't do anything from there. And it kind of a later time. But yeah, this it's 2002, like it's a bit later. But as an intro, it's a cool intro. Obviously, one of my favorites from the time. You were talking about it's this thing. Thank you, Sudden, for the links. I will look at them a bit later. Thank you. Yeah, this thing, but no, this is not the reference. I will show you the reference. So yeah, this scene. Yeah, I don't have text on Linux, sorry. So here's this random texture instead of it. This effect is... I'm not sure how it's called actually. It does have a proper name, but I don't know it. So basically the reference for this one is another demo from 90s. Gateways. It's not Linux problems. I didn't have text routines for Windows also, like for a longer time. Actually, it was... I think it's easier to do text on Linux than on Windows. I will show you my text routines in a bit. I just didn't make... don't have it implemented in this intro. So... in my demo tool. Девкис, привет. Okay, so this is the next reference, also like my favorite demos from childhood, and the reference scene for that is this one. So as you can see, like from 90s perspective, this looks like really amazing. Like it has this how do you call this in English? Lighting is amazing. It's like smooth surface and a lot of this. Basically, yeah. Again, with ray marching, everything is possible. This is just a ray march cylinder with noise and with proper like font shading. And also like scene here is greetings, and my scene is also greetings. Let me open YouTube to show you the greetings. And yeah, another thing that you're probably not seeing here, but it's obvious when I make it full screen, is this intro is actually rendered in 640 by 480. and then upscale to 1080p. So yeah. Okay. Next thing. I can show you like how this is made. This is scene number. I think I can figure this out from the looks of it. No, I can't. Scene number 6. Yes, scene number 6, which is down here. So yeah, this is modulation for it to be this wobbly. Interesting. Okay, I just made it to loop. Okay, let me disable the overlay here. Can I mute music? No, I can't. Okay, if I disable this one, a little bit less wobbly. Yeah, this is for like up and down, I think. Right? Yeah, you can see the effect. And hi Kenyan, welcome to the stream. You are looking at me explaining our 4K and 64K intros, which is like, are you familiar with demo scene? It's like, how do you explain demo scene? It's like a community of people doing amazing things with computers, and this is from our 4K intro, which is like executable in 4 kilobytes. Executable file with size no larger than 4 kilobytes, which renders graphics, music, and stuff like this. I will soon start explaining the next our intro, how it's made, like with shaders and all this, in a bit, and it will be, I think, more interesting than this one, because this one is kind of specific with its references to old demo scene. Okay, so yeah, this yeah, this one is just a cylinder with radius, and radius is modulated by 2 noise functions to get to frequencies of noise, and coordinates for that noise are cylindrical coordinates. First one is angle, and second one is y, height, basically. And that's the scene here. And next scene is like another thing that people used to do in 90s is real-time ray tracing, which is like really hard thing to do at the time because computers weren't fast enough, And as you can see here, like this entire intro is ray marching, which is even harder than ray tracing, computational wise. But yeah, and this is like to give this pixelated look of early ray tracers. Девки, да, мне 32 уже. Okay, спасибо. And yeah, the reference can be found in this intro for this demo, for example, like pixelated. There was another. There were a lot of scenes like that in those demos, so this is just reference to that. As you can see, like it's made by although flooring the pixel coordinates. So let me find it. Yeah, if I disable this, you will see that this is properly fine, and also like to simulate low frame rate also floors the time. So this is what it looks like without any it's fast. So there's that. And this scene is just engine placeholder for also trying to do this triangle flat shaded geometry look with the same floor, the normal effect. And that's it. That's the entire intro. It's not really interesting from native code standpoint, just regular C, and the code is the same as for the previous 4K intro, which I forget to show you, but yeah, it's the same. It's always the same. No assembly used here because they weren't really need for that, because it fit the 4K limit even when coded in C. Okay. I think this is the point where I make a short break. And after 5 minutes, I will explain the next and the next jetlag intro and the last one today, and the latest jetlag intro. And yeah, this as a finishing thing, this intro took fourth place, and people didn't really understand what we were doing here unless a bit later. It's hard to understand because it's all the entirety of intro is just reference to this specific time frame 18 years ago. So yeah, people are like, why all French groups greeted? Yeah, because those groups are amazing, and they hooked me up to Demasi. Okay, let's make a short break. Okay, welcome back. And I actually didn't check out this one yet, so try this function. Sorry for that. Okay, let's try whether it works out of the box. Okay, it does generate audio. I hope the audio is up to date. So this one is actually a 4K intro for function. Okay, let's wait. I think it will just show up. This intro is 4K intro that we made for function in Budapest, Hungary this September. As usual, as with other intros, it was made in a few days. Like maybe it took a week building this one. The idea for it we had been discussing for. Okay. So it basically works out of the box, but colors are weird. I will have to fix that. So yeah, I will close all of this, and this is a Posle. This 4K intro called Posle, which is like after in Russian. Post or after, something like this. Post something. It took first place, and well, yeah, it's although past racing. So let me show you. Okay, let me show you first how it properly I can show you the jetlag. Okay, so let's hope that this is because it's past racing. It's a lot of it's noisy as hell, and it's codec poison. Codec will be really bad at compressing it. So yeah, let me show you first how it looks like, and hear me. So yeah, that was the intro. Let's hope that you could see it. Just a second. Is stream okay? I think something was wrong with it. Okay. Everything went flying for some reason. So how it's made? It's basically a glorified 4K from KS construction, like not glorified, on steroids, I'd say. So it's basically the same. It's path tracing minus atmospheric light scattering, because it doesn't really make any sense here, and a lot of slightly more Raymarsh geometry. And yeah, no, not this one. Let me just close all of these. Function, right? For some reason it doesn't work. Player, привет и спасибо. So yeah, really the same approach. What's easy about this one is that basically material is always the same. The really different thing is like there's a lot of surfaces with not axis aligned, I'd say. So I had to calculate normal UVs based on that. So problem here was that I have a lot of geometry with different normals, with different like axis alignments, and I need to have UVs for that. And it's getting UVs for geometry in distance functions is not really a straightforward thing. You always like come up with some different ways to get the UVs. And well, here I made this normal to UV thing where I give it the pixel coordinates, not space coordinates of a point, and it's normal, and then calculate the UVs based on some. I actually forgot how I do this. So the idea here is to get some kind of basis that has two axes, one axis collinear with the normal, and other two axes just randomly picked from. So I just do it like this. Z is one, so basically X axis and Z axis. And then depending on which axis is better, like has better larger length, which is important in case if n gets collinear with x-axis, for example, we will get 0 here and it won't be great. So I pick the largest axis and pick it at first axis, and then second axis is just cross with normal with that axis, and basically that's the idea. So I pick random, pick some kind of bases are based on normal, and then just project our space point onto that basis. And that gives some kind of UVs which are orthogonal to the normal, which is what we want. And as usual, like the demo resolution here is 640 by 720, which is half of HD, not full HD, but HD. What else should I say? I should really show you some of these things, but for some reason it's not rendering right. And it's also really slow, and there's a lot of what's going on here? Maybe I need to fix not the tool, but okay, let me close this for now. Sorry about that, have to fix things. Tool video. The same tool, but different. Scenes. Otherwise, it's basically the same as for KS Constructions 4K intro. Okay, so shaders and splitter, right? So there's T, and I believe the render pass thing has F, not T but F. So to fix that, I have to have F here. No? Interesting. Frame F, right? F. This is important on Linux. No detail tool resize. Okay, let's do it like this. Clear 0. And then render pass. If clear, then and the frames per second are really low. Okay. What should I show you here? Yeah, as always, I forgot to say that the music for this intro was made for, as usual, by Keen. And it is amazing. It conveys the entire mood of this thing. Александр Патинок. Привет. Прости, если неправильно прочитал. Мои деватулсы просто полят. Просто полить сильно проще, чем возиться с Inotify. Inotify имеет смысл, если делать там если мониторить там кучу файлов, например. В данном случае, то есть просто сделать стат-вызов гораздо быстрее и проще, чем все остальное. Virgil 1974, привет. Привет. The previous question was, do I use file change time polling or do I use eNotify? And the slightly bigger reply for that will be that I tried to use iNotify for this kind of thing before in my demo tools, and it is not really convenient. The code for iNotify is kind of complex, not really complex, but it's not pleasant to work with. And there's no reason for that because I'm only monitoring a couple of files, and using single stat system call for that is simpler than doing a bunch of iNotify stuff. And it's quick enough. Капитан, привет. Я все время забываю, вот вначале это I или L? Это лайфхак сейчас называется ламп. Ай. Прости, я, наверное, еще буду забывать. Но... Алекс 1703, привет. The question was, do I have a new webcam? And no, I don't have one. I just have an old lamp that I bothered myself to switch on for the stream. There's also other issues with iNotify, which is like you really... what was that? It's not really convenient to track, like, for example, how Vim does update, Vim updates files. It renames the old file and creates a new one in its place, or something like this, I remember, and it confuses iNotify a bit. So yeah, basically I'm only trying to figure out whether my file with this name changed, so I do this stat call, and I check for both modification time and size, and then I ignore if something is wrong when trying to open this file. So it's really, really, really simple. I could probably show you the code for this, but it's platform independent, and there's a lot of macro around platform dependence. So yeah, this is metadata structure at size and time spec, and then there's this Linux stuff, which is stat call, and then getting metadata. Just read file metadata in a platform unspecific way. And then there's polled file, which is poll, read metadata. If it's not valid, just continue. If it's equal to the same, just continue. If you can't read the file, then just continue, and otherwise consider the file changed and return true. Store the old metadata and increment sequence number to, because there can be several dependents on the same file. I do this for название 64K intro, and there are many shaders there depend on lots of other shader files. So yeah. Okay. Just Virgil. Are you really a Virgil? The Virgil. Like If it really you, I know that you talk to Keen a lot, but I don't remember we had a chance to talk to each other, and I really must say that I appreciate what you're doing a lot, and I think you've been active for like 20 years or something, Demosynth. So when I just was a little kid, I used to listen to. So there's this how job, right? No, I can just look for virtual. I'll add there to else. And yeah, I remember a lot of stuff from how job. Elements. Yeah, Elements is one of my favorites. Okay. You did a lot of things. I'm just amazed. Thank you for that. What's my keyboard? Next question is like this. Das Keyboard. Or something. Okay, where was I? I was trying to explain things in this intro. So yeah, as usual, past racing setup with blending new frame with previous one. No text in this one. Tool is the same. Blitter is the same. It has slightly optimized ray margin setup, past tracing and information setup. Basically, there are 3 nested loops in this. I have no idea what color of the switches. I'm not into keyboards that much. I just wanted to try something that people around me were like talking good things about. Like there's this movement on like keyboards and stuff, and I bought one and it's okay. I'm not finding anything amazing about it. It's just a keyboard. What it made me do is like, because it doesn't have any labels on keys, it just completely, as you can see, like sorry about that, there are no labels on keys. So it made me actually learn how to type without looking at keyboard. I could do it before for some things, but not other. But still, I have trouble. Like if you type in some random characters, like lengthy random password, it's not convenient at all. I struggle a lot still. Okay, so this setup for this intro is... Я такую клаву, я ее просто по интернету заказывал, ее откуда-то вот, где ее производят, привезли. Она тогда еще, ну, конских, конечно, денег стоила, но не таких, наверное, конских, как сейчас. Okay, so there are a lot of scenes in this one, and scene is basically a number that is floor on time. Each 128 ticks, music ticks, those are music ticks that are tied to BPM. The scene changes to the next one. And for different scenes, I have different camera movements, so... What is the orient? The orient is basically camera direction, like look at. I don't have look at here, I believe. I don't have, and I have this Rust function which I didn't comment out and I don't actually use here. Yes, I about that a bit later. So camera movement based on like just rotation matrices and not a proper look at, because it doesn't make sense in this intro. It's really slowly moving, and the reason for slow movements is because this is path tracing and it has a lot of complex geometry, and it really is quite a bit more GPU intensive than the one for CC. The second before this intro, second last before this intro. So yeah, I was trying to tell you 16 samples per pixel. This is where I actually remembered to do proper anti-aliasing. So this is done with this thing where I calculate two rays for this pixel and for the next one, and then just linearly interpolate between those based on random sample number. Then there's next loop, which is for ray reflections, so 4 ray bounces around the scene. And the next loop is 40 ray march steps. Actually, what we can do right now, for example, is I was really unhappy about, as you can see here, you see the usual ray marching glitches where it doesn't have enough rays to get to the geometry. So what I can do here is actually ray march, ray steps, 80 for example, and here ray steps, and after the first one I do back to 40, and the idea, or even 30 for example, or even 20, it will still be, should be nice. The idea here is for the first array that goes from camera, we do more ray march steps to get rid of those artifacts. And for ray bounces, we can do quite a bit less ray steps. Let's look at this. So yeah, it suddenly became a bit better. Virgil, welcome back. If you are really the Virgil, I was telling a lot of stuff about like how I appreciate what you are doing and been appreciating like since I was myself a little kid. So yeah, thank you. So there's this quick fix for but let's return to 40 and it will be quite a bit more how should I say it? Brighter. Yeah, I've been streaming for 2 hours and my English gets worse and worse because I'm getting too tired. And also you can see the nuns here. Those black pixels are nuns, and there are only a few of them by the end of the intro, so I don't do anything to hide them. Another thing that I wanted you to what should I tell you about that? The geometry here is usual ray marching distance fields stuff, which is just constructed as directly as you might imagine It doesn't work like this. Where you have this is a box that is cut out from a box and another box, and all this stuff is repeated. And yeah, Mad Cactus, привет. And yeah, not really. It's not really interesting in a sense how this geometry is built. It's just simple Raymarsh. Distance feels as usual. What is probably interesting is one slight change that I made while I was building it. For most of the time that I was building it, it looked like this, I believe. Let me disable this. This is how it looked like. And at some point, I did a small change like this. And as you can see, this is a sun color. Sun color is, there is no atmospheric scattering here. It's just the sky is actually white. It's just white. We can actually try to do bluish sky, for example. Oh. Oh. This also makes it a little bit better. Okay. Okay. Yeah, I haven't thought about it when I was making. But yeah, as you can see, like there are always a little thing that you can tweak to make it a little bit better. Yeah, music in this one is amazing. I really love what Keen is doing, and yeah, I'm really grateful that for him to approach me, and that we could pair up and do things. Okay, I do like the blue sky a lot. Okay. So next, what should I tell you next about this? I think the intro code itself, like native code C1, is the same as for previous intros. Basically, it's just two frame buffer and frame buffer and screen, and two shaders. And the last scene is obviously like too similar to the one from KS Constructions. And this is basically because I ran out of time to do anything clever here. So we did have a better idea what to do with the last scene. But unfortunately, we lacked time to properly implement it. And another thing is that, the intro itself was made during the week before the party, with most of it done during Friday and Saturday before the deadline. But Keen, I think Keen had music quite before that. As usual, like King does have a lot of stuff ready. Yeah, another thing that I wanted to tell you about this is that it's a reference. So there's actually a reference for this intro, and let me Google it up. I believe I don't have any images of the references between. Why the what are these? What is YouTube recommending me? What did this? So abandoned nuclear plant. This one. At some point, YouTube basically recommended me a video. I was watching some Russian guy who was some diggerish kind of guy who was visiting a lot of like abandoned places, subways and stuff like this. And YouTube recommended me a video from these like American, I believe they are American, dudes visiting an abandoned nuclear power plant. And I immediately noticed that this is actually 4K intro material because of this simple geometry. And you can see the references here, right? In these scenes. And so yeah, you do see references. This basically scenes are really similar. This one, for example. So yeah, basically random YouTube recommendation resulted in 4K intro. Thanks, Google. As for the part that I didn't finish is these things. I did have them in code. And although these Rust things and let me actually show you some Rust. And I mean not programming language, but actual material Rust. I haven't finished it, unfortunately, so doesn't really work. It's not finished and the colors aren't really there. But this is what I was working on. So yeah, there's quite a bit more content to this. I think I don't have any hidden scenes. I think we used everything that we made. Probably float bulky. Holes. Yeah, holes are these probably. This I don't remember what. No, these are for this scene. The next one. So yeah, I didn't finish with the Rust. How do you say this in English? Translate. Google. Smudges, yeah. Sounds right. So these smudges. But I did really plan to do them. And we plan to separate a different ending and yeah. But I'm happy that we didn't actually ruin the idea. Matte tracing. What is matte tracing? Саш, привет. Gekarka asks, whether I noticed the Soviet experimental architecture, like houses on small legs, and I think, well, I did see a lot of stuff, but I'm not sure what you're talking about. Past racing, but somehow started working before we finished implementation. We have met racing. End of time. What? Yeah, this one I was like really confused as how it's done. Yeah, this looks by Best Racing G. This one, yeah. This is a good one. Yeah, this is good. Okay, I want. I can show you it on my stream, but it's kind of I'm not sure that well. I'm not sure. I really try to like limit other content on my stream for just to reference points for like copyrightish reasons. Okay, there's an explanation. It traces primary name normally, registers samples on the way one or less random sample in the reflection direction at every step. What? It is. Okay, I got it. They effectively produce magnetic light. So no, it's traces it's ray marching plus. So it's volumetric. Per each ray marched sample, you calculate normal, even though you didn't hit any geometry, but just there's still like defined normal for distance fields, and yeah, volumetric lighting with directional glow. Yeah, secondary samples, primary hit surface, the remaining duration, early exit and tracing them. Still conversion. I'm not sure I understand what this part is about. Direction computed normally as your direction by the normal and roughness, but there's only one sample taken at the best known proximity of the reflected surface and higher sample from the shaded point. Yeah, but I kind of understand how something like this might arise from writing past tracer. It's really cool that you find the use for this.